give Ely a break while we have a presentation from our second speaker. Khaled El-Tahlawy is from Cairo. He's a researcher in the Textiles Research Division of the National Research Centre. And because of the importance of textiles to Egypt, there are about 100 people in the Textiles Research Division. There are various interests in Chitosan fibres for medical textiles, and so some new work is being presented here, and we look forward to what you have to say. Thank you very much.
Thank you much for the introduction. Ladies and gentlemen, mentors, units. Chitosan is in the acylated form of chitin that's produced by alkaline treatment of chitin at higher temperature. Chitosan is a biocompatible, biodegradable, and non-toxic material. Linking of cyclodextrin to Chitosan is getting one of our interest areas, since this may be due to the unique properties of the resultant product. Preparation of beta-cyclodextrin grafted Chitosan was achieved by the following. The first one is preparation of reactive cyclodextrin by the reaction of beta-cyclodextrin with citric acid at different action conditions. The second one is linking of beta-cyclodextrin citrate with Chitosan at various reaction conditions. The third one is utilization. The third one is utilization of the final product. Starting by the first point is preparation of beta-cyclodextrin citrate. Beta-cyclodextrin citrate was prepared by the reaction of cyclodextrin with citric acid in presence and absence of sodium hypophosphite as a catalyst under curing condition. It is well known that citric acid has 3 carboxyl groups, so at higher temperature, anhydride intermediate, reactive anhydride intermediate is produced, which attack the cyclodextrin OH groups and forming beta-cyclodextrin citrate. From this finding, we can conclude different factors affecting the preparation of beta-cyclodextrin citrate, which are sodium hypophosphite concentration at different reaction temperature, reaction duration, material to liquor ratio, and for sure, citric acid concentration. Figure 1 shows the relation between sodium hypophosphite concentration and extent of esterification expressed as carboxyl content in milli-equivalent per 100 gram modified cyclodextrin. It is clear from the data that increasing sodium hypophosphite concentration from 0 to 0.5 mole per 1 mole citric acid is accompanied by increase in the carboxyl content of cyclodextrin citrate. At the same time, regardless sodium hypophosphite concentration used, the carboxyl content is increasing by raising the reaction temperature from 80 to 140. The third point here is very, very important, that at 0 sodium hypophosphite concentration, we got a promising result, since the purification of the final product is much easier than in presence of sodium hypophosphite. Actually, the enhancement in the grafting in the esterification reaction could be attributed to the enhancement in the water dehydration. The second one is the formation, much easier for formation of the reactive anhydride intermediate, and consequently the esterification reaction as a whole. The second factor, which are the reaction duration. It is expected that prolonging the reaction time from half hour to 3 hours is accompanied by increase in the carboxyl content of beta-cyclodextrin citrate. Actually, we are doing esterification reaction for cyclodextrin in a semi-dry process. So it is expected that the water content is playing an important function during the esterification reaction. Since the water content is playing an important role in the homogenization of the acting ingredient and the availability of citric acid in the vicinity of cyclodextrin molecules. For that, it is clear from the data that increasing the material to liquor ratio from 0 to 0.6 milli water content per 1 gram of cyclodextrin is accompanied by increase in the carboxyl content till 1 to 0.6 and then start to decrease. When is this reaction at two different temperatures, which is 100 and 120? Actually, it is expected, the increase is expected, but the decrease in the carboxyl content may be due to the dilution of the reacting reaction, and which may need much reaction temperature, elevation of the reaction temperature, or prolonging the reaction time to take the water out of the reaction. The fourth factor is effect of citric acid concentration. Actually, it is expected increasing citric acid concentration will accompany by increase in the carboxyl content of beta-cyclodextrin citrate. Now, we prepare beta-cyclodextrin with carboxyl content 270 as a reactive cyclodextrin and use it as a reactive cyclodextrin to react with Chitosan at different action temperature. So it is expected that the different factors affecting the grafting process will be formic acid concentration, cyclodextrin citrate concentration, reaction temperature, material to liquor ratio, and for sure the molecular weight of Chitosan. The formic acid concentration, it is clear from figure 5 that increasing the formic acid concentration from 0 to 0.4 milli of formic acid per 1 gram of Chitosan is accompanied by increase in the graft yield percent. So the increase in the graft yield percent may be due to three reasons actually. The first one is the solution of Chitosan itself. Increasing formic acid increases the solubility of Chitosan, and consequently increase the homogeneity of the reacting ingredient. And third one, increase and enhance the condensation reaction. Figure 6 shows the relation between cyclodextrin citrate concentration and graft yield at different at two times for undissolved Chitosan at 0 formic acid and dissolved Chitosan, which is 0.4 milli per 1 gram of per 1 gram of Chitosan. We show here both of them the reaction, the efficiency of the grafting reaction expressed as graft yield percent is increasing with increasing cyclodextrin citrate. But we can show that at 0.4 milli of formic acid there is a big difference between both of them. Figure 7 shows the relation between the reaction temperature and the extent of grafting expressed as graft yield percent. As it is well known that the condensation reaction, or the reaction temperature is playing an important function during the condensation reaction. So it is expected that the effect of the reaction temperature will give us a promising result. It is clear we did the reaction, the grafting reaction, at two different concentrations of formic acid. At 0 formic acid for undissolved Chitosan and dissolved Chitosan. We show that in case of undissolved Chitosan, the increase in the reaction temperature is accompanied by increasing the graft yield percent. That is to say that there are the reaction temperature is directly proportional to the graft yield percent. But in case of dissolved Chitosan, we surprise with something that increasing the reaction temperature from 80 to 100 is accompanied by increase in the Grafted percent. Further increase above this temperature is accompanied by a decrease in the Grafted percent. This decrease could be attributed to the formation of N-Chitosan furanate rather than condensation reaction, which means that the number of amino group, the number of accessible amino group in the chitosan along with the chitosan backbone is decreased as a result of side reaction. Figure 8 shows the effect of material to liquor ratio on the Grafted. Actually, we find that the optimum material to liquor ratio is 1 to 15 milli of the water content. And also it is well known that decrease here in the Grafted percent may be due to the dilution reaction of the reacting ingredients. Effect of the molecular weight of chitosan. Actually, molecular weight of chitosan is playing an important function during the grafting percent. Since the grafting efficiency is inversely proportional to the molecular weight of chitosan. Chitosan having molecular weight, lower molecular weight, giving us high Grafted percent, which may be due to the lower viscosity of the acting ingredient, less steric hindrance, more mobility of the reacting ingredient, and all of these reflect the condensation reaction. After that, we prepared three kinds of cyclic-strain grafted chitosan with three different molecular weight of chitosan. We expressed the antimicrobial activity of chitosan and modified chitosan as minimum inhibition concentration, at which this means that the concentration at which all the microorganisms are killed. Here we notice that the MIC is highly dependent on the deacetylation of chitosan, molecular weight of chitosan, and the concentration of chitosan, and finally the kind of functional group introduced to the chitosan backbone. For that, we can conclude that it's expected that decreasing the molecular weight of chitosan itself is decreasing the MIC. And actually, we use two types of microorganisms, which are gram-positive and gram-negative. Here, decreasing the molecular weight of chitosan. Here, this is the chitosan. We use here 25 milligram. Here, decrease the introduction of beta-cyclogen citrate to the chitosan backbone decrease the MIC from 25 to 12.5. This is almost for all these groups. Actually, we have to take in our mind that beta-cyclogen citrate itself don't have any kind of antimicrobial activity against the studied microorganism. But we can conclude also to that the linking of cyclic-strain citrate with chitosan improve the antimicrobial activity of chitosan itself. This is what we can conclude. Actually, there is another extension for this work is the use of the final product as carrier for different kind of drugs. Thank you. Any questions?
We have time for questions. Yes.
Sorry. I know the exact reaction the mixture must contain initiator, vinyl monomer contain double bond, for example, and the reaction contain or grafting polymerization through the opening for on the double bond. Is there in your work, is there a double bond initiator and this? So it must we can say that instead of graft yield percent, we can say, for example, reaction percent.
Actually, the work of grafting is not necessary for vinyl polymerization. Vinyl polymerization is one of the use. Do you know what I mean? So the meaning of grafting is you can use it in a lot of things, not only during the polymerization action. And there is a lot of literature talking about the grafting. It's not graft copolymerization.
As I know, that is a different kind of fact. Look, grafting or graft copolymers, or there's different type of that. Each one depends on the finite or a block of monomer attached together if it's a straight line or it's a branching line.
So you object from the use of...
This is esterification reaction.
Actually, esterification reaction is the first one, is the preparation of cyclodextrin citrate, but in the other step is grafting. Not the meaning of grafting is not polymerization, just polymerization. The use of word of polymerization is one of the use of the word of grafting. Okay.
One more question, and we'll move on.
Actually, this is very, very, very good question. Because suppose at high temperature and in the presence of citric acid, the cyclodextrin ring may be open. And this is right. And actually, when we are planning this work, we take care of this point. For that, if you, I think in one of our chart, we use the reaction temperature at 100 only. We don't exceed the reaction temperature above 100, because actually increasing the reaction temperature above 100, especially starting from 120, cyclodextrin ring start to open. But let me tell you something. It is very important to optimize the concentration of citric acid and the reaction temperature, because this is the rule. This is the two reasons for opening the cyclodextrin ring. So we just use trying to use low concentration of citric acid and mild condition. For that we use just carboxyl content to 270. But actually we use here, we reach to more than 350. But we try to select the optimum condition for preparation of cyclodextrin.
The second expectation reaction for citric acid is done. I think it's done at 140.
No, 120. Yes, the cyclodextrin is on. Thank you.
Thank you. Well, thank you very much indeed. Sounds like you'll have some good conversations afterwards. I think there may be a slight culture clash here between sort of clothing engineering, computing interests and the textile chemistry, but we'll, there are certainly conversations to follow up from this session.